The lesson outcome for this video is, I can solve a system of equations by substitution. We've learned already how to solve a system by graphing, and our solution always is a point or an ordered pair, x, y, where the x and the y values in the coordinate pair are true for both equations in the system. So we will do the same, we will find the same type of solution by substitution. It's just going to be a different method of getting there. So first of all, let's talk about the word substitute. To substitute is the act of putting one thing in place of another thing. We've actually already used substitution in math this year, and one way we've done that is down here, y equals 5x plus 3, and it says find y when x equals 2. So anytime we're trying to find the y value when we know the x value, we're actually substituting. So we're going to put what x is equal to, which is 2, we're going to substitute that 2 in for x in the equation. So we've done this before, y equals 5, and we can substitute the number 2 in here, that's what x is, right there, and now we're just going to simplify. So y equals 5 times 2, order of operations, 5 times 2 is 10, plus 3, so y equals 13. So just to show you, you've already done a little bit of work with substitution, it's just a little different when it's a system. So here's our first example of finding a solution to a system of equations by substitution. Again, earlier this chapter, we've already found the solution to this system by graphing 5x plus 3, y equals 5x plus 3, and graphing y equals 2x minus 12 on a coordinate plane, and then finding the intersection of those two lines, and that would be the solution. Well, now we're going to solve the system by substitution. So, first of all, just like on the previous page, what we want to do is we want to find something that we can substitute into another equation for that variable. So for example, I can say, well, if I know that y is equal to 5x plus 3, that means this 5x plus 3 can be substituted anywhere that I see a y, because they are the same. If they're the same, you can substitute one for the other. So since we have 5x plus 3 is equal to y here, we can take that 5x plus 3 and we can put it in anywhere else, in a different equation, for example, where we see a y. So that's what we're going to do. We're going to substitute 5x plus 3 in for the y here in the other equation. When we do that, we get 5x plus 3 equals 2x minus 12. Okay, so notice the 2x minus 12 is still right here, and the equal sign is still here, but the y has been replaced with 5x plus 3, because that's what we substituted in for y. And now we have an equation that we already know how to solve. We'll go ahead and subtract 2x from both sides of the equation. And we get 5x minus 2x, which is 3x, plus 3 equals negative 12. All right, now we will subtract 3 from both sides. And we get 3x equals negative 15, because negative 12 minus 3 is negative 15. These canceled. And lastly, we solved for x by dividing by 3 on both sides. 3 divided by 3 is 1, so we have 1x equals negative 5. Now once we solve and we get x equals negative 5, you have to be really careful. That is not our final solution. Remember, a solution is an ordered pair. X and y are needed to tell the final solution. So if we know that x equals negative 5, what we need to do now is our second step, and that is take either of the two original equations, it doesn't matter which one, and we're going to put negative 5 in for x in one of the equations and then solve for y. So I'm going to go ahead and use the very first equation here, and I have y equals 5x plus 3. We're going to put this negative 5 down here in for x, just like we did on the previous page. So negative 5 is going to go up in here for x. That's a negative 5 there, sorry. All right, and then we have the rest of that equation. So now we have y equals 5 times negative 5 is negative 25 plus 3, which means y equals negative 22. So now that we know that x is negative 5 and y is negative 22, we can write our final solution as negative 5, negative 22. Again, x coordinate first, y coordinate second. And had we graphed our original two equations up here, the intersection of these two lines would have been where? Well, the intersection of the two lines would have been at -5, -22. Okay, so one more example. Notice in this example we have one equation in standard form and one equation in slope-intercept form. That's fine, it doesn't make a difference as long as we know what one variable is equal to. And in this case we do. We know that y is equal to 3x plus 1. So that means 3x plus 1 can be substituted in place of a y variable anywhere that we see a y variable. Since we see one right here, we can take this 3x plus 1 and put it in place of y, because we know that is what y is equal to. So when we rewrite this, we're going to get 2x plus 3 times y. Now instead of y, right, instead of the y, we're going to put 3x plus 1. When you do that, you need to put this in parentheses. Okay, equals 14. And now we're going to solve this. When we solve this, we distribute the 3 into the parentheses. So we get 2x plus 3 times 3x is 9x plus 3 times 1, right? We're distributing here. 3 times 1 is 3 equals 14. Now we will combine our like terms. 2x and positive 9x, that makes 11x plus 3 equals 14. And now we're going to subtract 3 from both sides of the equal sign. We get 11x equals 14 minus 3, which is 11. And we're going to divide both sides by 11. When we do that, we get x equals 1. Now, the last thing we need to do is we need to find out what our y value is, because remember, our solution is going to be an xy coordinate pair, and we do know that x is 1, because that goes right there, but we still need to know what y is. My suggestion to you is you always go back to that original equation where it says y equals 3x plus 1. So we know that y equals whatever 3 times the x value is plus 1. And we know the x value over here, down here, is 1. So we're going to go ahead and put that x value in. So y equals 3 times 1 plus 1. So y equals 3 times 1, which is 3, plus 1, which is 4. So now we know our y value is 4, so we can put that right here, and we have our solution, 1, 4.